Question number 8, A part, compare decision tree, random forest and boosting, highlighting strength and weaknesses of each. Model, decision tree, its strengths are simple to understand and interpret, handles numerical or categorical data, needs little data pre-processing, work for both classification and regression, whereas its weaknesses are highly prone to overfitting, high variance, small data chains, gives different trees, may create bias split when a data is imbalanced. The random forest strengths are reduce overfitting using bagging, more stable than a single tree, work well on a high dimensional dataset, good accuracy and robustness, weaknesses, less interpretable in symbol for many trees, uh, slower training than a single tree, larger number of tree gives high memory usage. Boosting its strength is build a strong learner from week one, excellent performance on structured tabular data, focuses on misclassified sample, high accuracy can model complex relationship, whereas its weaknesses is sensitive to noise and outliners, require careful toning, learning rate depth, slower training compared to RF random forest and a tree decision tree. Question number 8b part, explain the architecture and the component of Hadoop HDFS, Yarn, MapReduce or Spark and its advantages over MapReduce. Answer, Hadoop is an open source framework for distributed storage and processing of large dataset. Its core components are HDFS, Hadoop Distributed File System. This is a storage level layer of Hadoop. HDFS, Hadoop Distributed File System. It is a storage layer of a Hadoop. HDFS break large files into a smaller block and distribute them across multiple nodes in a cluster. It ensures data redundancy and a fault tolerance by repeating these blocks. Name node, the master node in HDFS. It stores metadata about the file system, example file name, location of a block. Data node, slash node that stores the actual data blocks and provide read and write operation as instructed by the name node. Yen, yet another resource negotiator. Yen is a resource management layer responsible for managing cluster resource and scheduling application. The resource manager, the master daemon in Yen, it allocate resources, CPU and memory to application across the cluster. Node managers place daemons running on each node. They manage resources on their respective node and communicate with the resource manager. MapReduce an programming model and processing framework for parallel processing of a large data set. Map phase process input data in parallel, transforming it into a key value pair. Process phase aggregate and process the output from a phase to produce the final result. Question number 9, A part. Obtain a basic logic gate from a neural network. Summarize them in a table with a number of neurons, activation function, and the back propagation in neural network, if any. Answer is neural network can implement basic logic gate using spectrums. A spectrum takes weight input and passes the result through an activation function, usually steps or sigmoid. Some gates like XOR needs multi-level network. The AND gate uses per spectrum weight W1 equals to 1, W2 equals to 1, biases is B equals to minus 1.5. Output activities only when both input is 1. Activation is step function whereas backprop needs no single layer. OR gate using per spectrum weight is W1 equals to 1, W2 equals to 1, biases is B equals to minus 0.5, output 1 if any input is 1. Activation step functions backprop needed is no, it is also single layered. AND gate weight equals to W equals to minus 1, bias B equals to 0.5, convert the input, activation steps, back probe needed, no. XOR gate using neural network. XOR is not linearly separable, so it cannot be implemented using a single neuron. It required multi-layer per spectrum. Hidden layer, 2 neuron, outer layer, 1 neuron. Activation sigmoid ReLU. Back probe needed, yes, to train a multi-layer weight. Now we will summarize using table the logic gate and the number of layer is 1 because it is a single per spectrum. Neuron also uses 1. Activation function is step and sigmoid. Backprop required is no. It is same for NOT and OR. Whereas in XOR, the number of layer is 2, multi-layer network. The neurons needed is 2 hidden plus 1 output equals to 3 neuron. Activation function is sigmoid and LERU. The web prop is needed, yes. The question number 9b, compare CNN, RNN, GNAN and transfer learning in terms of architecture and application. CNN is convolutional neural network. RNN is recurrent neural network. GAN is generative adversarial neural network. And transfer learning. The primary architecture of CNN is feed-forward network with convolutional layer, pooling layer, and fully connected layer. Primary architecture of RNN network with loops and cycle that allow information persistence and flow through time sequence data. In GAN, two competing network a generator create data and a discriminator evaluate a data trend simultaneously. In transfer training, it methodology, not a specific architecture that refuses an existing pre-trained model architecture like ResNet or BERT or on a new task. The key mechanism of CNN the key mechanism of CNN is feature extraction using shared weight across spectral data image, capturing patterns like edge, texture, and object. In RNN, the gating mechanism LSTNS and GRU, and internal memory to process sequential data, text, time, and series by takes time series by passing hidden state between time stop. In GAN, a zero sum game adversarial training where both network improve each other. The generator learns to produce realistic data. The discriminator learn to better identify fake data. In transfer learning, leveraging pre-existing knowledge, weight and bias from large generate general data set to solve a similar but specific, often smaller data problem efficiently. And the CNN application are image classification, object detection, image segmentation, computer vision, facial recognition. The application of RNN is natural language processing (NLP), speech recognition, machine translation, time series prediction, sequence generation. Application of GAN is image and video generation, data augmentation, creating data art generation, anomalies detection. For transfer learning is medical image analysis with small data sets, sentiment analysis using pre-trained language model, any task where a relevant pre-trained model exists.